Hello students, now we are going to start 45 problem assignment on ray optics. First problem is from AIPMT 1994 and 1989. Ray optics is valid when characteristic dimensions are much smaller than the wavelength of the light, much larger than the wavelength of light. Of the same order, you know that wavelength of light is very less in 10 to the power minus 6 meter. So you can deal only with if objects are much larger than the wavelength of light. So we will go with option B. Second, a tall man of height 6 feet want to see his full image, then the required minimum length of the mirror will be, it is from 2000 AIPMT. I told you we need a lens mirror which should be half of the length of height. So we need at least 3 feet high mirror. Next, green light of wavelength 5460 angstrom is incident on an air glass interface. If the refractive index of glass is 1.5, then the wavelength of light in glass would be, it is from 1991 AIPMT. We know that what is refractive index of any medium? Wavelength of light in air upon wavelength of light in medium. In this, we want the wavelength of light in glass. So it should be its wavelength in air 5460 divided by its wavelength mu. What is the value of mu? Mu is 1.5. Mu is 1.5. So remove this decimal, you will get 10. 15 threes are 45. Remaining is 9. 96. 15 6 are 90. 60. 15 4s are 60. So we are going with A. Third, A. Fourth, again they ask 2 times 91 and 92 in AIPMT. Continuation 2 year. A beam of monochromatic light is refracted from vacuum into a medium of refractive index. The wavelength of refractive light, just we saw that. What is mu of medium? Wavelength of light in air or vacuum upon wavelength of light in medium. So in medium, wavelength of light should be equal to wavelength in air upon mu. For each medium, mu is greater than 1. So wavelength will decrease. Wavelength will decrease, but they are talking about, yes, wavelength. So we will go with B smaller. Next, 1993 AIPMT. Time taken by sunlight to pass through a thickness 4 mm whose refractive index is 3/2. We know that in any medium, what is refractive index of any medium? Speed of light in air upon speed of light in medium. So first we will calculate the speed of light in that medium. So it should be speed of light in air upon refractive index of medium. Speed of light in air is 3 into 10 to the power 8 meter per second. Refractive index is 3/2. So in that medium, light will travel with a speed of 2 into 10 to the power 8 meter per second. But we know that what is speed? Speed is equals to distance upon time. So what time it will take to cross this distance? Distance is 4 millimeter. 4 into 10 to the power minus 3 meter upon. What is speed? 3 into 10 to the power, speed is 2 into 10 to the power 8 meter per second. So 2 2s are 4. Take 8 in numerator. So you will get 2 into 10 to the power minus 11 second. So we will go with option C. Next, it is from 1996 AIPMT. Light travels through a glass plate of thickness T, whose refractive index is mu. C is the velocity of light in vacuum. Time taken by the light to travel this thickness. Again, we know that what is mu? Speed of light in air upon speed of light in medium. So in this medium, speed of light should be C by mu. But speed is distance upon time. We want to cross a thickness T. Suppose time is, this is time, distance upon time. So what time it will take? Mu T by C. So we will go with option D, sixth D. Seventh, it is from 1996 AIPMT. The refractive index of water is 1.33. What will be the speed of light in water? They asked in 1996 AIPMT. Again same formula. Mu of water, it should be speed in air upon speed in water. So speed in water should be 3 into 10 to the power 8 divided by 1.33. 1.33 means 4 by 3. So what we are getting? 9 by 4 into 10 to the power 8. Nearly 2.25 into 10 to the power 8 meter per second. So we are going with B option. Next, it is from 1997 APMT. If mu naught, epsilon naught are the electric permittivity and magnetic permeability. Mu naught means permeability, epsilon naught means permittivity. Mu and epsilon, they are for medium. The refractive index of the medium is, we discussed in previous unit. So we will go with formula B. Ninth, it is from 1997 AIPMT. Again, electromagnetic waves. Frequency is n, wavelength is lambda. Traveling with a velocity v in air enters a glass slab of refractive index mu. The frequency, wavelength and velocity of light in the glass slab will be. We know that frequency will not change. It depends upon the source only. So it means either A option is correct or C option is correct. D option is correct. So we will go for V upon mu is same in both. So we will go for wavelength. So we can recognize this. What is the relation of refractive index with wavelength? What is the relation of wavelength and refractive index? Mu means wavelength in air upon wavelength in medium. So in that medium, wavelength will become lambda upon mu. So we are going with option D. It is 10th problem, which is from 2000 AIPMT. A bubble in glass slab when viewed from one side appears 5 cm, from another side 2 cm. Actual thickness of slab is, it is a glass slab. It is air bubble. It is a air bubble. When you are viewing from one side, suppose from this side, actual distance is x, and from this side actual distance is y. When you are viewing from upper side, what is mu? Mu is real depth upon apparent depth. When you are viewing from upper side, they are saying it is 5. So what is x? X is 7.5 centimeter. From downside, actual depth is y, but they are saying 2. So what is y? It is 3 centimeter. So what is actual thickness? Actual thickness means x plus y. So it should be 7.5 plus 3 means 10.5. So we are going with C. Next, it is from 2004 AIPMT. A beam of light composed of red and green rays is incident obliquely at a point on face of rectangular glass slab. When coming out on the opposite parallel face, the red and green rays emerge from A, 2 points in two different non-parallel directions. Any ray, when passing through a glass slab, what is happening? What color it may be? From rarer to denser towards the normal, away from normal. It will go parallel to the incident ray. We have proof in our 11th class, 12th class. So, the ray, when they will come out parallel. But what they are saying? So, first option is wrong. C option is wrong. 2 points propagating in two different parallel directions. Since wavelength is different, so they will go from two different points but parallel directions. So we are going with B. 2006 AIPMT. A microscope is focused on a mark on a piece of paper. It was piece of paper and it is the mark. So what is its actual depth? It was its distance from your microscope. And you focused it. But what will happen when you put a glass slab of thickness 3 centimeter? In glass slab, it will come up. By what distance? We know that mu is equals to real depth. Real depth is 3. Apparent depth, suppose x. So x is 2 centimeter. So if you put glass slab of thickness 3 centimeter, it will appear at 2 centimeter, means it will move in upward direction. Its image will move in upward direction by 1 centimeter. So again, to take it in focus, you have to move your microscope upward in 1 centimeter. So we will go with option B. Next, it is from 2007 AIPMT. The frequency of a light wave in a material is this, wavelength is this. The refractive index of material will be. We know that frequency of light is same everywhere. It is not changing. It is not changing in any medium. But when they are saying the wavelength is 5, material is frequency of a light wave in a material this and wavelength is this, you can calculate the speed of light in medium. V is equals to n lambda. Frequency is 2 into 10 to the power 14 and lambda in this medium is 5000 angstrom, means 10 to the power minus 10 meter. So what we are getting? 5 into 2, 10. 1 0 is this and 14 this, 5 0. So what we are getting? 14 and 1 15 and 3 18. 18 minus 10, 10 to the power 8 meter per second. So it means the refractive index, which is equal to of medium, speed of light in air upon speed of light in medium. In air it is 3 into 10 to the power 8 meter per second. In medium we are getting 10 to the power 8. So what we are getting? We are getting 3. So refractive index should be 3. So 13th B option. 14th, a small coin is resting on the bottom of a beaker filled with liquid. A ray of light from the coin travels up to the surface of the liquid and moves along the surface. Moves along the surface, it means at this point angle of incidence is equals to critical angle. If refractive index of this liquid with respect to air is mu L. If this angle is I means critical angle, this angle should be critical angle. It is all again critical angle. If this side is 3, this side is 4 by Pythagoras, this side we will get 5. We will get this angle 5. What is sin C? Sin C means perpendicular upon hypotenuse 5. But sin C is 1 upon mu. It means refractive index of your liquid, it should be 5 by 3. But refractive index is equals to speed of light in air upon speed of light in medium. So, in this medium, speed of light should be c upon mu L. What is c? In air, light travels with a speed 3 into 10 to the power 8 meter per second, and mu L is 5 by 3, take 3 in numerator. So, 9 by 5 means 1.8 into 10 to the power 8 meter per second. So, we will go with option D. 14th D. 15th, it is from 1994 AIPMT. A small source of light is 4 meter below the surface of water of refractive index 5 by 3. In order to cut off all the light coming out of the water surface, minimum diameter of disc placed on the surface of water is, again fish type of problem is there. Fish or source is here. Light will go outside only from a circle of radius r, and r you can calculate by the formula h upon under root mu square minus 1. H is, source is at a depth 4. Mu is 5 by 3, so it will become 25 by 9. It will become 25 by 9. Means 4 into 3, 25 minus 9, 16, 4 will come out 3. So, radius is 3, so diameter which is double the radius, it should be 6 meter. So, we will go with option A. 16. A ray of light from a denser medium strikes a rarer medium. The reflected and refracted rays are perpendicular to each other. We want to calculate critical angle. Critical angle means if this denser medium is glass and this rarer medium is air. We know that A mu G is equals to 1 upon sin C. Means sin C is equals to G mu A. Take this sin C on that side, A mu G on this side. G mu A means now rays are travelling from glass to air. So, sin I is I upon sin R is R dash. But for law of reflection, I should be equal to R. So, we can write I sin R, law of reflection. Since this angle they are saying 90 degree and total angle of one side of a line is 180. So, R plus R dash, it should be 90 degree. So, for R dash we can write sin 90 minus r. So sin C is equals to sin r upon sin 90 minus r means cos r means 10 r. So C should be sin inverse 10 r. So we will go with option A, 16th A. 17th, it is from 1998. Light enters at an angle of incidence in a transparent rod of refractive index, and for what value of the refractive index of the material of the rod the light once entered into it will not leave it throughout the lateral surface, whatsoever be the value of angle of incidence. You have complete derivation in your 12th class in optical fibers. We know that in this case mu should be greater than root 2. So we will go with option A. Next, it is from 2000 AIPMT. Rainbow is formed due to. Rainbow is the combination of refraction and total internal reflection. So for this, which answer we should go? Internal reflection, and rainbow means 7 color. 7 color means dispersion. So internal reflection and dispersion. So we will go with option B. Colors are not due to diffraction or interference. Next, it is from 2001 AIPMT. A disc is placed on a surface of pond which has refractive index 5/3. Source of light is placed 4 meter below the surface of liquid. The minimum radius of disc needed so that light is not coming out is. Again they repeat the problem, just we solved it. So we will go with so 19th options, but now they are asking radius. At that time they asked diameter. So radius should be 3 meters. Next, it is from 2001 AIPMT. A ray of light traveling in air has wavelength lambda, frequency and velocity v, intensity I. If this ray enters into water, then these parameters are changed. Which relation is correct? We know that when light is entering from one medium to another, frequency remains same. So we will go with B option. Again from 2001, optical fibers are based on the total internal reflection. Next, for the given incident ray as shown in figure, the condition of total internal reflection of this ray will be satisfied if the refractive index of the prism will be. See what is happening here. This angle is 45 degree. Light is entering from this and it is angle of refraction. What is mu? If refractive index of this material is mu of this ray prism, it is a prism suppose made up of glass, mu is equals to sin I upon sin R. It is sin 45, sin I is 45 degree, sin 45 degree by sin R. So sin 45 is 1 by root 2. So mu g is equals to root 2 sin R. If this angle is R, this line is parallel to this line. This angle is 90 minus R. It is 90, so it should be R. And this angle should be 90 minus R. Total internal reflection will take place at this surface. If for this surface the refractive index is like such that this angle will become critical angle only then internal reflection, means TIR, will take place if this angle of incidence is equal to critical angle. It means 90 minus R, it should be equal to or greater than critical angle, means sin 90 minus R. It should at least greater than or equal to sin C, minimum sin C. Sin 90 minus R means cos R. What is sin C? 1 upon mu. But what is cos R? Cos R is under root 1 minus sin square R. It should be 1 upon mu. Not writing mu g, we are writing mu only. Mu. But sin R is mu by root 2. So what we are getting? Squaring both sides, 1 minus sin square R means mu square by 2 is equals to 1 upon mu square. It means 1 is equals to, what is sin R? Root 2 by mu, sorry. It should be sin R is mu by root 2. What we are getting? Mu is equals to sin 45 by sin R. So sin R we are taking on this side, sin 45 1 by root 2. We will correct this. What it is? Sin 45 means 1 by root 2. So sin R means 1 upon root 2 into mu. Sin square R means 1 upon 2 mu square. So 1 is equals to, take 1 upon mu square common, 1 plus 1 by 2 means 3 by 2. So 3 by 2 mu square is equals to 1. So mu square is equals to 3 by 2. Therefore mu is equals to root 3 by 2. So minimum value of this mu is root 3 by 2. So we are going with option C. 23rd, it is from 1988 AIPMT. Focal length of a convex lens of refractive index 1.5 is 2. When lens is immersed in a liquid of refractive index, what will happen? We know that focal length in air can be calculated by lens maker's formula. When rays were entering from air to glass, very important result. So I am explaining in detail. We will use that result for some another problems. Now we want to calculate focal length in some liquid. What will happen? Rays will enter from liquid to glass now. Divide first equation by second. So in liquid focal length upon in air focal length, it is A mu g minus 1 upon L mu g minus 1. Give it equation number 1. We know that if rays are travelling from air to glass, glass to liquid, finally coming in same medium, product should be 1. We need L mu g, take G mu L on that side. So what we are getting? L mu g is equals to A mu g upon A mu L. It means FL is equals to FA into A mu g minus 1 upon A mu g by L mu g minus 1. What we are getting this result now? If a lens goes into a liquid whose refractive index is greater than the refractive index of the material of lens, what will happen here? If denominator is greater than numerator, this number will be greater than 1 and you will get one negative sign. Means behavior of lens will change. If it is convex, it will behave like concave. If it is concave, it will behave like convex. Sometimes they are asking, air bubble in water will behave like, refractive index of air is nearly 1 and water is 1.33. Means a convex air bubble is going in a liquid whose refractive index is greater than the refractive index of this bubble. So nature will change, so it will behave like a concave mirror. What will happen if A mu g and L mu g are equal? 1 minus 1 0 something upon 0 infinity. Means it will disappear. You cannot see it. It will behave like a glass slab. Now we will move to this problem. We are putting the values. What is FA? Focal length of a convex lens of refractive index 1.5. In air it was 2 centimeter. It was given 1.5 minus 1 upon 1.5 upon 1.25 minus 1. So 2 into 1.5 minus 1 means 1 by 2.5. Take LCM, 1.5 minus 1.25, 0.25 upon 1.25. Cancel 2 with 2. 0.25 upon 1.25, 1 by 5. So what we are getting? 5 centimeter. So answer we got 5 centimeter. 1995 AIPMT, a lens is placed between a source of light and a wall. It forms images of area A1 and A2. For the two different positions, the area of source of light formula is root A1 A2. Direct formula they are asking, so we will go with C. Next, it is from 1996 AIPMT. FV and FR are focal lengths of a convex lens for violet and red light. Capital FV and capital FR are focal length of concave lens for violet and red light. Then we know that what is the formula for focal length? I am talking about convex lens whose focal length is positive. So 1 upon F is equals to mu minus 1, 1 upon R1 minus 1 upon R2. I told you in VIBGYOR, with respect to mu, it is a decreasing order. Mu is maximum for violet and minimum for red. It is decreasing order. And for wavelength, it is increasing order. If mu is greater for some color, this number will be more. Since F in denominator, so F will decrease. For violet and red, for red mu is less, for violet mu is greater, mu have greater value for violet. So for violet, F should be less, means for violet focal length should be less than for red. But for concave, since minus sign is there, so in positive number is decreasing, in negative it is increasing. Getting my point? So FV is less than FR because it is convex, but for concave it will be reverse. I am saying 5 is greater than 2, but minus 5 is less than minus 2. So we are going with option B. 25th, we are going with option B.